This is lesson 5.3, part 1. We are going to solve quadratics using the quadratic formula. So, we have just gotten done learning about completing the square. And so just to review that, let's go ahead and solve this equation, which is a quadratic equation for x by completing the square. And so go through the steps that we do. So remember, leading coefficient is 1. And so I'm going to take this first part right there and I'm going to complete that square. So I'm going to take half of 4, which is 2, and I'm going to square it. And then I can take it away. And so what that does, remember, is it just makes it so that nothing really happened. Okay, that's one way to do this. The other way is I could complete my square, and I could add the 4 and then add it to the other side as well, and then take the 10 away. So both of those are good ways to do it. It doesn't really matter, but you want to just kind of pick what works best for you. Okay, what I have now is my perfect square, so x minus 2 quantity squared. I have got plus 6 equals 0. So I'm going to have x minus 2 quantity squared equals negative 6. I'm going to now take the square root of both sides. So x minus 2 equals plus or minus. The square root of 6 is square root of 6, and then the I is going to come out for the negative. So then for my solution, I'm going to have x equals 2 plus or minus I square root 6. And so that's going to be my solution, and that's by completing the square. Okay, the next quick review. This one does not have a 1 coefficient, so we have to deal with that. So on this one, we have a couple of choices. We could divide everything by negative 2. And when I say that, everything has to be divisible by 2, by negative 2. And if it's not, then you have to go and do something else. Dividing everything by negative 2, that's not that hard. And so what I want to do is I actually want to do the factoring option, because if you get something where everything's not divisible by your leading coefficient, it's a lot harder to remember how to do the factoring part. So let's practice with the factoring because we can. So what we're going to do is we're just going to look at the first two terms, just the x squared and the x. Don't worry about the 12. In fact, we can, well, we'll keep it on that side for a minute. So I'm going to take the negative 2. I'm not going to do a GCF because I still want to have the x squared inside. I just want to get that coefficient out of there so I can complete the square. And watch your signs when you do this, because you need this to be a negative 4 right there, because negative 2 times negative 4 is positive 8, and that's what I want. And then I'm going to leave some space to complete the square. I've still got the plus 12 equals 0. Okay, so that's what I've got. Now to complete the square, I'm going to take half of 4, which is 2, and square it, which is 4. What did I really just do? I did not really just add 4. I really subtracted 8, so I'm going to add 8. Or you could subtract 8 from the other side, one or the other. So I'm going to write negative 2, and then my perfect square trinomial, and then the 8 plus 12 is 20. Now I'm going to take the 20 to the other side, and then I'm going to divide everything by negative 2, and then I'm going to take the square root of both sides, and then I'm going to solve for x. So I have my two solutions. Now, it would have been easier, yes, to divide everything by 2, but like I said, the problem is that sometimes we can't do that. It doesn't work, and remembering how to factor it takes a little bit more work. So I wanted to show you another example of when we do that. Okay, the last one, you notice that we've got x squared here, we've got this on the other side. Okay, that we cannot complete the square with. So in order to complete the square, you have to have the x squared and the x on the same side. So x squared minus 5x. Now if I wanted to, I could put the 84 on the other side right now, or I could leave it on the left-hand side. It doesn't matter. I'll just go ahead and move it. I need to complete this square. So I'm going to have x squared minus 5x. Now take half of 5 and then square it. So that's going to be plus. It's always plus because when you square something, it's always positive. 25 over 2. Sorry, not over 2, over 4. And then that means that I have to add 25/4 to the other side as well to keep it even. On the left, I have my perfect square trinomial. So remember that what you put right here is going to be the square root of that. Don't forget the square. Sometimes people forget that, and it makes the whole thing different, so be really careful. Now this part, I'm going to have to use my common denominator, so I need to make common denominators for that. So the easiest way is just to do 84 times 4. So 84 times 4 is 336. So 336 plus 25 is 361. So this is 361 over 4. Okay, now I'm going to take the square root of both sides. So I'm going to have x minus 5 halves equals plus or minus. Now the square root of 361 fourths, I know that the square root of 361 is 19, and the square root of 4 is 2, so that works out. And then I'm going to move my 5 halves to the other side. Oh, sure, sorry, that should be a 2, not a 4. Okay, now you're not done, because you can do 5 halves plus 19 halves and 5 halves minus 19 halves. So you need to do that. You can't leave it any other way. So we've got this, and that can reduce to 12, and this one can reduce to negative 7. So that just tells me, because those are two integer answers, it told me that at the beginning, if I would have realized it, I could have factored. The difficulty with factoring, like we've said before, is that sometimes you know you can factor it, and sometimes you just try to factor it and waste your time because you can't do it anyway. So factoring works sometimes. Completing the square always works, but we see how it's kind of problematic when we have fractions to deal with. So that kind of creates this other problem that we have. So let's go ahead and go into a discovery mode here. I was wondering what happened to 4 when I was doing this, and then I realized I had taken it off because I didn't want the lesson to be too long. So anyway, we don't have a number 4. Okay, so we're going to take any quadratic equation and we're going to solve it for x. So x equals what? Now when we look at a quadratic equation, this is what we call standard form. And so we have ax squared plus bx plus c. So if we have like 3x squared plus 2x plus 5, that's a quadratic equation, and I would say that that's my a, that's my b, that's my c. Now I could solve that by using completing the square. That doesn't look very appealing to me because those numbers look terrible. If I did that, I'd have to factor out the 3, and then to factor the 3 out of the 2, I'm going to be left with 2/3. And then I'm going to have to do half of 2/3, which is 2/6, so 1/3, and then I'm going to square that, so plus 1/9, and then what did I really do? I really just added 1/3, so I'm going to take away 1/3. That just doesn't look very appealing. That looks kind of horrendous. So let's try to do a standard rule, okay? So the standard equation, ax squared plus bx plus c equals 0, we can actually solve that for x. Now, what we cannot do, you can't do something like divide by x, because if x was 0, then you just made the whole world explode. So we can't do that. We are going to use what we've just been doing with completing the square. We're going to use the same process, but remember that we're not having any actual numbers right now. We have variables a, b, and c. So what we're going to do is we're going to approach this the same way. Let's look at our leading coefficient, which is a. So I'm going to take a out of that. Now we run right into what I was just showing you with that other problem, but in order to solve this for x, we're going to have to deal with that. So I'm going to have to say plus b divided by a, because if I did a times b over a, it would be b. So that's factoring it out. And then I'm going to leave space to complete my square. And then I have that. Oh, by the way, I should tell you that this is going to be a test question. So you will have to show me how you solve this equation by completing the square. So you will have to show that. So you want to make sure you're paying really close attention to how, because memorizing it is kind of difficult. You have to understand how you're doing it so that you're not having to wonder what comes next and just guess. Okay, so the next thing we're going to do is we're going to complete this square right there. So I'm going to take b over a, and I'm going to take half of it. So that's b over 2a. And then I'm going to square it. So what I'm going to put right here is I'm going to put plus b squared over, well, actually, let me write it as b over 2a, and I'll just put squared like that. Okay, now the big question is, of course, what did I really just add? I really didn't just add b squared over 2a squared. I really did this. So I did a times b squared over 4a squared. And so I have to do that to the other side. So I'm going to, I'll just add it right here. So I'm going to add a times, I'll just keep things like that for right now. Okay, and so I'm going to have my perfect square. Okay, remember it's half of the b divided by a, so it's b over 2a like that, quantity squared. I'm going to move my c to the other side, and I've got plus, and then I'm going to have ab squared over 4a squared. Okay, now let me erase some of this other stuff I have over here. Okay, now we need to think about what can I simplify. So let's look at the right-hand side. On this fraction right here, I have a and I have a squared on the bottom. So I can write the negative c, and then I'm going to have plus b squared over 4a, like that. Okay, on the right or the left-hand side, nothing's changed. All right, so now the next thing I'm going to do, I'm going to focus again on the right-hand side, and let's write that with a common denominator. So if I'm going to have a common denominator, that is going to be 4a. So I need it to be 4a, so that one's not a problem. It's already got that. So I'm going to have to multiply this by 4a over 4a. So I'm going to have negative 4ac over 4a, like that. So I just made a common denominator. That's all I did on the right-hand side. Didn't do anything on the left-hand side. I'm going to write this over here as one fraction over 4a. The negative 4ac plus b squared, I'm going to write that in standard form. So I'm going to do the b squared minus 4ac, so it's in standard form. And then, again, nothing is changing on the left-hand side. Okay, the next thing that I'm going to do is I am going to get the a out of here, because in order to solve for x, I'm going to have to take care of that eventually. So I can divide by a, but then you come over here and divide by a. That's kind of messy. And so another way we can look at that, remember, we've talked about this a lot of times before, is you can multiply by 1 over a. And then that cancels, and I can multiply by 1 over a. Now keep in mind, like I've said before, a had better not be 0 here, because if a is 0, then I've just done a lot of things that I shouldn't do. Like I've got that, and I've got that, and I've got that. So we've got a lot of problems if a is 0. So one of the things about a quadratic is that a cannot equal 0. If you think about it, if a was 0, would you have a quadratic? It wouldn't even be a quadratic, because that's not even there. It would be linear. So a is not 0 here, and so that's good, because like I said, that would be a big problem. But I'm going to multiply by 1 over a. So what I have left on the left-hand side is my perfect square. On the right-hand side, the way you multiply fractions, remember, is you're going to multiply across the top. So I just have b squared minus 4ac, and then on the bottom, 4a squared. Okay, I'm ready now to take the square root of both sides, because there's nothing else I could do. So I'm going to have x plus b over 2a equals plus or minus, and then the square root of b squared minus 4ac over 4a squared. Okay, a couple of reminders about this. When you have a plus or a minus sign under your radical, you cannot take the square root of that and the square root of that. It does not work like that. So you will have to leave those together. So those are kind of joined. There's nothing you can do about that. However, you can separate your numerator from your denominator. And I can do something with that denominator. So what I have for my denominator is I have 2a. On the top, I have my plus or minus, because I have my plus or minus with something, so I'm going to put it there. And then I have my x plus b over 2a. I'm almost where I've solved for x, so I'm almost there. So what I'm going to do is I'm going to take away my b over 2a, so I'm going to have x is equal to, and then we have negative b over 2a plus or minus the square root b squared minus 4ac over 2a, and because they both have the same denominator, then I can write that as a single fraction. So as a single fraction, I'm going to have negative b plus or minus the square root of b squared minus 4ac all over 2a, and I've solved for x. What that means, this is a really significant finding, what that means is this is x in any quadratic equation. All you would need to know is what is a, what is b, what is c, and you could plug those numbers in. This is the quadratic formula. Now, when I was in high school and I learned about the quadratic formula, I never learned how to find it. I just thought somebody made it up. And amazingly enough, it worked, but I never really thought about why. And so understanding that this is actually the solution for any quadratic equation, that really helps a lot, because then you understand, like, this is why it works. So if you have any quadratic equation, you can solve it for x. It doesn't matter if you're going to have irrational or imaginary or real roots. It doesn't matter. You can solve it using the quadratic formula, and that is what is so awesome about it. So the quadratic formula is x equals negative b plus or minus, that gives you your two solutions, the square root of b squared minus 4ac all over 2a. So like I said, on your test, you're going to have to show how you start here and how you end up here. And so I do have a separate video that just shows this, but you'll need to be able to go through that process. So it's very important that you do that a few times yourself and make sure you understand. This is a really fun song about the quadratic formula. There's one that everybody sings, and I think it's dumb. It isn't even funny. Anyway, it's okay and everything, but this is a really fun song. So I'll probably play this in class if we have time, but if not, that's a really fun song, and I've got it linked on the website, but if you are on Canvas, if you want to listen to it. But let's get on with how you use the quadratic formula. So you're going to use this to solve any quadratic equation, and that's the great thing about it. So just like completing the square, it always works for any quadratic equation. You don't have to wonder if you can factor it. You don't really have to deal with the fractions as much as you do with completing the square. You don't have to worry about factoring things out. So it's really nice, okay? It will find any types of solutions, real, imaginary, rational, and irrational, all of them. So in the next video, we're going to go through and practice using the quadratic formula to solve equations.